Calculus examples, trigonometric functions. This is video 34, example 3. Find the derivative of the function y equals 4x cubed e to the 5x sec squared of x using the alternative technique and then using the product rule. To review the above videos, you should pause this video now. All videos have been written and produced by Michael J. Bankhead. Example 3. Find the derivative of the function y equals 4x cubed e to the 5x sec squared of x using the alternative technique and then using the product rule. Solution. Finding the derivative of the function y using the alternative technique. The function is: Step 1. Apply the verbal form of the alternative technique. The derivative of y is dy by dx equals. The right-hand side of y is this expression, so substitute. Multiplied by is times. The derivative of is d by dx of. The line of is line of. The right-hand side of y, as before, is Step 2. Bring down. Use the laws of logarithms to simplify the line function. Using L1 in Reminder 2, Scene 5, it can be shown that since W is 4, line of W is line of 4, plus is plus. Since x is x cubed, line of x is line of x cubed, plus is plus. Since y is e to the 5x, line of y is line of e to the 5x. which is 5x. Plus is plus. Since z is sec squared of x, line of z is line of sec squared of x. Bring down. From reminder 2 in scene 5, since y is 3, replace y with 3. Since x is x, line of x is line of x. Bring down. Since y is 2, replace y with 2. Since x is sec of x, line of x is line of sec of x. To review the above working, you should pause this video now. Write the last equation in scene 2 as Step 3. Bring down. This derivative equals 0 because line of 4 is a constant. Plus is plus. Bring 3 down as 3 times. This derivative equals 1 over x, and 3 times 1 over x is 3 over x. Plus is plus. This derivative equals 5. Plus is plus. Find the fourth derivative using the verbal form of the chain rule for y equals line of f of x. Bring 2 down as 2 times. This derivative equals the derivative of the argument of line is the derivative of sec of x, which is sec of x tan of x, divided by is divided by the argument of line as before is sec of x. 2 times sec of x tan of x divided by sec of x is equal to this expression. Now cancel sec of x with sec of x. Call this equation equation 1. Step 4. Since equation 1 can be simplified, it must be simplified. Bring down. Since the denominator is x, separate out x. X cubed becomes x squared times x. Bring down. Bring this entire bracket down. Bring down. X times 3 over x is 3x over x. Now cancel x with x. Plus is plus. X times 5 is 5x. Plus is plus. X times 2 tan of x is 2x tan of x. Therefore, dy by dx equals bring down. Bring this entire bracket down as. To review the above working, you should pause this video now. Finding the derivative of the function y using the product rule. The function is Step 1. Reminder. Apply the verbal form of the product rule. The derivative of y is dy by dx equals. The second function is sec squared of x, so substitute. Times is times. The derivative of the first function is the derivative of 4x cubed e to the 5x. However, since 4x cubed e to the 5x is the product of two functions, 4x cubed and e to the 5x, apply the verbal form of the product rule. The product rule again. The second function is e to the 5x, so substitute e to the 5x times is times. The derivative of the first function is the derivative of 4x cubed, which is 12x squared. Plus is plus. The first function is 4x cubed, so substitute 4x cubed. Times is times. The derivative of the second function is the derivative of e to the 5x, which is 5e to the 5x. Do not forget these brackets. Now continue with the first product rule. Plus is plus. The first function is 4x cubed e to the 5x, so substitute. Times is times. The derivative of the second function is the derivative of sec squared of x, which is 2 sec squared of x tan of x. Call this equation equation 2. Bring down sec squared of x times e to the 5x times 12x squared becomes 12x squared e to the 5x sec squared of x. Sec squared of x times plus 4x cubed times 5e to the 5x becomes plus 20x cubed e to the 5x sec squared of x. Plus is plus. Bring down as. Call this equation equation 3. Step 2. Since equation 3 can be simplified, it must be simplified. Bring down. Separate out 4x squared e to the 5x sec squared of x from all 3 terms. Bring 12x squared down as 4x squared times 3. Bring this expression down. Plus is plus. Bring 20x cubed down as 4x squared times 5x. Bring this expression down. Plus is plus. Bring 8x cubed down as 4x squared times 2x. Bring this expression down. Bring down. Therefore, dy by dx equals, factor out 4x squared e to the 5x sec squared of x from all 3 terms, giving 4x squared e to the 5x sec squared of x times bring 3 plus 5x plus 2x tan of x down as. To review the above working, you should pause this video now. Reminder 1. The function is apply equation 4. Bring down. The right-hand side of y is this expression, so substitute. Multiplied by is times. The derivative of is d by dx of. The line of is line of. The right-hand side of y, as before, is Reminder 2. To review the above reminders, you should pause this video now. Reminder 3. The function is in scene 4. The first function is 4x cubed e to the 5x, and the second function is sec squared of x. So the derivative of y must be found using the product rule. Reminder. The verbal form of the product rule is shown below, followed by the derivative of y dash of x equals. The second function is sec squared of x, so substitute sec squared of x times is times. The derivative of the first function is the derivative of 4x cubed e to the 5x, which is this expression, plus is plus. The first function is 4x cubed e to the 5x, so substitute 4x cubed e to the 5x times is times. The derivative of the second function is the derivative of sec squared of x, which is 2 sec squared of x tan of x. Thus, after applying the verbal form of the product rule, y dash of x equals bring down, bring down, bring down, which is identical to the right-hand side of equation 2. Scene 4. To review the above reminder, you should pause this video now. When solving questions from your textbook similar to the example in this video, 1. If you intend to find the derivative using the alternative technique, you should display scene 2 followed by scene 3 so you can use them as templates to find the derivative. Note that there is no need to factor out 4x squared e to the 5x or sec squared of x. See scene 2 and scene 3. 2. If you intend to find the derivative using the product rule, you should display scene 4 so you can use it as a template to find the derivative. You should then find this topic simple and beautiful. Cheers! Do not forget to check your answers with the answers in the back of the textbook.